Hello everyone, my name is Collin Borns and I'm the head of business development at Speechly. And today I'm going to be talking to you about Reactive Voice UIs, which is a new model for building voice-enabled experiences that is made possible by the technology that we have been building at Speechly over the last handful of years. But before getting into the specifics of the technology that we have built, first I want to give some background on the Speechly team. We have built an experienced team of industry veterans who have been building the previous generation of voice technologies, such as Apple's Siri and Amazon's Alexa. Our headquarters is in Helsinki, and our US headquarters is here in Chicago. Our team is also very close to academia, and a significant share of our team have backgrounds in machine learning research. And we have spent the last 4 years building our technology from scratch to fill in the gaps specifically with the current generations of voice technologies. And our technology stack is 100% proprietary. So we've built our own speech recognition and natural language understanding engines into a technology that we call spoken language understanding. Next, I want to start by providing a little bit of context and actually describing Reactive Voice UIs. And I think the easiest way to do this is to directly compare Reactive Voice UIs with the traditional assistant-based voice UI. So first off, Reactive Voice UIs are optimized for task completion. This is different from voice UIs, which are optimized to have conversations with users and the voice assistant. Next, Reactive Voice UIs are characterized by multi-modal UI mechanics, with voice going in and then visual out being the primary mode of interaction. Assistant voice UIs have voice go in and then have voice come out. With a Reactive Voice UI, the information exchange between the user and the UI is single turn and command and control focused. But with this, the UI and the user communicate with one another in both directions simultaneously with visual responses. And this is contrary to an assistant voice UI that is turn-based and conversational. The communication is one direction at a time and therefore not simultaneous. Finally, Reactive Voice UIs bring voice as a feature alongside other modalities. So the idea is not to substitute an existing graphical user interface with voice, but rather to complement or augment it along the parts of the user journey that would otherwise be tedious for the user. This is contrary to voice assistants, where voice is the UI, but it's also the operating system. And here is an example of a Reactive Voice UI in action. Show me Samsung TVs from $400 to $750. Before going into more of the specifics of Reactive Voice UIs and some of the different use cases, I want to give some background on the progression of voice technology in general and why we take this approach at Speechly. So I want to start by going back to the year 2016. And this was a special year for us because that was the year that Speechly was founded, but it was also a pretty special year for voice technology in general. We saw a lot of interesting advances on the tech side happening that year. For example, we saw speech recognition reaching human parity in some of the classic conversation speech recognition benchmarks. And then on the business side of things, we also saw platforms like Alexa taking off, and we saw Google coming out with their own smart speaker voice assistant. So all in all, there was a lot of optimism and momentum around the promise of voice technology. However, if you fast forward 5 years later to this year, the advancement has actually continued and accelerated rather rapidly. Now we have superhuman accuracy in both speech recognition as well as natural language understanding for many of the most well-known speech recognition and natural language understanding benchmarks, some of which are listed here on the screen. However, the status of voice as a UI and as a UI modality isn't anywhere close to where user expectations were set just a few years ago. So today, voice is still pretty much a niche that is only used for a handful of rather simple use cases. So despite the great advancements in technology with superhuman accuracy, I think most people here would probably agree that the reason voice is still a niche is that many voice-enabled experiences deliver a low-quality experience to users that have very high expectations. So the question really is, what do we do about it? And it all starts with looking back at the two things that I just mentioned: quality and user expectations of voice-enabled experiences. Let's start with looking at quality. But first off, what exactly is quality? The classic definition is that a product is of high quality if its performance meets expectations. The problem with voice-enabled experiences today, though, is that expectations have been set extremely high. But more often than not, the value delivered by voice experiences is actually rather low. So simply put, voice experiences being built today are just not meeting the expectations of users. So again, there's this question, what should we do? And I'd say the answer is actually rather simple. There needs to be reasonable expectations set with users, but also we need to focus on building voice experiences that actually add value. And in the remainder of this presentation, I'm going to show you how this can be achieved with reactive voice user interfaces. All right, let's start with the easier of the two problems, which is managing expectations. The easiest way to start managing expectations is by using all of the tools that you have available. The best use cases for a voice UI today exist in domains where we are already spending a lot of time, such as mobile apps and on the web. So users, by nature, already have access to a screen. And this should be used to your advantage when creating voice-enabled experiences to better manage those user expectations. Now let's actually talk about why. It's standard for voice assistants to come with a human persona and traits. This is with the intention of creating some sort of emotional attachment to the user of the assistant to ultimately make it more friendly and helpful. However, humans are really good at detecting fakes, and the closer something tries to resemble a human, the more disturbing even the slightest mistakes become. So with the voice assistant approach, you are setting an extremely high user expectation, equal essentially to a human-grade assistant for the experience. And if you have interacted with a voice experience that did not quite live up to this expectation, you have experienced something that is called the uncanny valley. However, with the reactive voice UI approach, you look to add voice as a UI feature to a screen and leverage standard graphical user interface elements to make it obvious for the user that they are operating a machine. There is no illusion of a person. And by adding voice as a feature to the visual UI, you are just making a machine more powerful. The difference in the approaches are essentially going from trying to interact with an abnormally behaving person to controlling a highly functioning machine. The second thing that a screen helps you with is scoping the context of the user experience. Voice UIs typically suffer from users not knowing exactly what they can do or say, or what features are actually supported by the experience. However, most applications in the world are very narrow at what they do. They are designed to just do a few things, but they're designed to do those few things very well. And the same applies to voice UIs. Voice UIs should use the visual elements of the screen to limit the domain and make sure the user understands what the voice features can actually be used for. There are already existing UI conventions for doing this, so we really do not have to reinvent the wheel here. The UI on the left ultimately gives no hints to the user on what they can do with the voice experience. However, the voice application on the right makes it obvious for the user that this should be used to book flights. Finally, as opposed to voice being the actual operating system, we at Speechly believe that voice is more effective as a UI feature that is optimized to work alongside other UI modalities such as touch and visual. Voice should ultimately complement or augment the user experience along the parts of the user journey where there is friction. Adding a mic button to a search or an input box is a great example of this in action. It's a low-hanging fruit to make a user's life easier, especially on mobile, for doing a task that is frequently repeated. So now that we have talked about setting user expectations, next let's talk about how to raise the bar in terms of value delivered from voice-enabled experiences. And the secret sauce is something that we call real-time spoken language understanding. But before discussing some of the specific benefits and details of spoken language understanding technology, I want to give some background on AI experiences in general. So, AI-based product experiences have the characteristic that when they work well, they work magically. However, when they go bad, they usually fail catastrophically. For instance, autonomous driving, a magical experience could just be simply going back and forth between work and home. However, if one day you were to drive off a cliff, that could be pretty catastrophic. Or with voice, for example, a magical experience could be something as simple as nailing a pizza order on your way home from work. However, it could be pretty catastrophic if the experience accidentally called your ex-girlfriend. A major reason AI experiences like voice are still struggling is that the failures are just too costly today. And you can tackle this really in two ways. The first is to make the AI perfect, or the second is you can try and make the failures cost less. And we at Speechly believe that the latter is the more feasible and valuable path in the short term. However, there is something else that we need to acknowledge. Verbal communication is by nature very error prone. If you look at humans are just not that good at spoken language understanding. The typical human word error rate is around 5%. Put in other words, if a sentence is 10 words long, you will have at least one word misunderstood in every other sentence. However, the difference for humans is that missing a word here or there is not very costly, as we are really good at recovering from those mistakes using things like context. So then the question is, what ultimately makes communication successful? It's really all about short cycles, incremental delivery, being iterative, failing fast, getting feedback, delivering value early, transparency, and adaptation. And if you look closely, these principles are actually the very same principles of efficient modern-day software development, and also aligns with the core principles behind developing reactive voice user interfaces. So to illustrate this, let's look at how a traditional voice UI experience is built. It starts with speech to text, and this is where a text transcript is generated based on what the user says. Once the user has stopped talking, the natural language understanding kicks in. And this is where the system starts to actually make sense of what the user wants to accomplish, or put in other words, the intent of the user. Once the intent is figured out, the next step is figuring out what to actually respond back to the user, which typically with voice assistants is some sort of spoken response. So as you can see, it's a sequential or waterfall process where the value is delivered at the very end. However, also the errors during the process are silently accumulated and also only surfaced at the end, making it impossible to recover for the user. This is different with reactive voice UIs and real-time spoken language understanding. As opposed to the UI making sense of the users only after they have finished talking, real-time spoken language understanding starts to make sense of the user immediately as they start to speak. The idea is to maintain a fast feedback loop, delivering value early, as well as in error situations, failing fast so that the user can recover. This way, the errors are not compounding until the end of the experience, and it gives the user the ability to get back on the happy path. Finally, the combination of real-time spoken language understanding and a screen with visual feedback creates a completely new way for us to input and process information with a computer that is truly full duplex. And this is contrary to an assistant voice UI that is term-based and conversational. Humans cannot speak and listen at the same time. This is just a fact. And therefore, the communication is one direction at a time. And as a result, information can only be exchanged so efficiently. On the other hand, it is easy for humans to process visual information and speak at the same time. And with reactive voice UIs, the UI and the user communicate with one another in both directions simultaneously. So rather than a slow or back and forth exchange of information, like you might find with a voice assistant, reactive voice UIs allow for an efficient input and response of information that is not restricted to voice alone. All right, but that's enough theory for one day. Let's now look at some reactive voice UIs in action. This first example is from the B2C side, focusing on voice search. So as we all know, online shopping is full of friction, but this can be removed by adding voice as a feature to make existing shopping experiences more efficient. Show me men's sneakers from Puma. Actually, Adidas. No, let's go with Nike and make that black, actually red, size 11, and sort by price. No, let's go with black. As you could see from this example, the user received visual feedback in real time while they were still speaking and were able to make edits instantly. This gave the user the confidence to continue on with the task and to do it quickly. Virtually every single website and application collects some information from users, and oftentimes this can be quite tedious. But what if you could just speak to any form and it would just fill in quickly and accurately? Here's how that would work in practice using the context of flight booking. Book a round-trip flight from Chicago to Miami, departing tomorrow and returning January 31st. And do that for 3 passengers in business class and direct flights only. Again, the visual feedback gives the user the confidence to continue with more complex utterances than you might expect from a typical voice-enabled experience. All right, with this next demo, we know that our day-to-day life is full of tedious tasks where we spend hours that we could spend doing other more valuable things. And I think that online grocery shopping is one of those that a lot of us have had to become familiar with over the last few years with the pandemic. But here's an example of how we can make this task easier using voice. Apples, fair trade coffee, organic oranges, free range eggs, bread, orange juice. Let's change up the bread. Whole grain looks good. Let's check out. In this example, it's good to notice the power of multimodality. Imagine how frustrating it would have been to change the bread using a conversation. But by just touching and selecting, this was done in a second. When the focus is on building a conversation, these kind of things can easily be overlooked. Reactive Voice UIs, however, always focus on solving the user's problem in the most efficient way, using the available modalities to the user's advantage. All right, and now here's an example of a reactive voice UI from the B2B side. A lot of companies are looking into voice UIs to make their professionals more efficient. And this is pretty obvious because the business case is actually pretty simple. More efficient employees equals more productivity. Phone +1 312 983 0743. Email edwin.collins@acme.com. Deal size 60 kilos. Probability 70%. Set stage to proposal. Notes: Edwin was very interested in our solution for the web. Had problems integrating existing solutions. Will decide by next month. John Brown was mentioned as the technical contact point. His email is john.brown@acme.com. Tasks: send Edwin the deck by next Monday. Book a meeting with John Brown by next Tuesday. Again, here you can see how the real-time visual feedback gives the user confidence to continue with their extremely complex utterance. Imagine having to capture all of the structured data in a conversational manner again and again. And I'm not sure if you noticed in the demo, but Speechly can actually detect entities in real time from the user's speech. All right, so now I just want to give a quick recap of the key components of a reactive voice user interface. So first and foremost, it's optimized for task completion. Voice should only be used for what it is good for. If it is getting in the way of completing a user's task, it's probably not adding any benefit to the user experience. The next is voice in, visual out. Voice experiences should not be limited to back and forth conversation. Remember to always take advantage of screens. Next is full duplex and the command and control approach. When taking advantage of screens, you create more efficient communication between a user and a computer. But you should remember that voice should not be humanized. It is best used for command and control of a system. And this leads to the final point of voice as a feature. The best voice experiences use voice alongside existing modalities to improve an existing experience. Thank you everybody for joining and for watching this today. If you have any questions at all or any ideas or a specific use case or maybe you want to do a proof of concept, please feel free to reach out to me directly. The email is listed here, collin@speechly.com. And please follow us on Twitter and LinkedIn. You can find us just by searching Speechly. Thanks again for watching today.